Hello, can everyone hear me? Okay, so last stream I learned about composition and aggregation. This stream I would be learning about inheritance. Hold on, let me just change the full screen. Okay, so last stream I learned about object relationships, composition, aggregation, association, and dependencies. And this stream I'll be learning about inheritance. Okay, introduction to inheritance. In the last chapter, we discussed object composition, where complex classes are constructed from simpler classes and types. Object composition is perfect for building new objects that has a relationship with their parts. However, object composition is just one of the two major ways that C++ lets you construct complex classes. The second way is through inheritance, which models and is a relationship between two objects. Unlike object composition, which involves creating new objects by combining and connecting other objects, inheritance involves creating new objects by directly acquiring the attributes and behaviors of other objects and then extending or specializing them. Consider apples and bananas. Although apples and bananas are different fruits, both have in common that they are fruits. And because apples and bananas are fruits, simple logic tells us that anything that is true of fruits is also true of apples and bananas. For example, all fruits have a name, a color, and a size. Therefore, apples and bananas also have a name, a color, and a size. We can say that apples and bananas inherit all of the properties of fruit because they are fruit. We also know that fruit undergoes a ripening process by which it becomes edible. Put into a diagram, the relationship between apples and bananas and fruits might look something like this. So apples are fruits, bananas are fruits. The diagram defines a hierarchy. Hierarchy is a diagram that shows how various objects are related. Most hierarchies are either most hierarchies either show progress over time or categorize things in a way that moves from general to specific. If you have ever taken biology, the famous domain, kingdom, phylum, class, order, family, genus, and species ordering defines a hierarchy. Here's another example of a hierarchy. A square is a rectangle, which is a quadrilateral. Square is a rectangle, which is a quadrilateral, and a right triangle is a triangle, which is a shape. Okay. Basic inheritance in C++. Let me open the other chapter as well, and the other chapter as well. Now we have talked about what inheritance is in an abstract sense. Let's talk about how it's used within C++. Inheritance in C++ takes place between classes. In an inheritance is a relationship. The class being inherited from is called the parent class, base class, or superclass. The class doing the inheriting is called the child class. So apple is a child, fruit is a parent, triangle is a parent of right triangle, shape is a parent of triangle, and square is a child of rectangle. A child class inherits both behaviors and properties from the parent. Here's a simple class to represent a generic person. Person, it has a name, age, and you construct it like this. And then it has these two functions. Because this person class is designed to represent a generic person, we have only defined members that would be common to any type of person. Note that in this example, we have made all of our variables and functions public. This is purely for the sake of keeping these examples simple right now. A baseball player class. Let's say we wanted to write a program that keeps track of information about some baseball players. Baseball player need to contain information that is specific to baseball players. For example, we might want to store a player's batting average and the number of home runs they have hit. Here's an incomplete baseball player class. So baseball player, average, home runs. Now we also want to keep track of the baseball player's name and age, and we already have that information as part of our person class. We have three choices for how to add name and age for baseball player. Add name and age to baseball player class directly as members. Add person as a member of baseball player using composition. But we have to ask ourselves, does a baseball player have a person? No, it doesn't. So this isn't the right paradigm. Have baseball player inherit those attributes from person. Remember that inheritance represent an is-a relationship. Is a baseball player a person? Yes, it is. To have a baseball player inherit from a person class, the syntax is fairly simple. After the class baseball player declaration, we use a colon, the word public, and the name of the class we wish to inherit. So class baseball player public person. This is called public inheritance. We will talk about what public inheritance means in the future. So person, which is a parent of baseball player. Baseball player object will have four member variables: batting average and home runs from baseball player, and name and age from person. Baseball player Joe dot m name Joe, and then Joe dot get name. This prints Joe. Now let's write another class that also inherits from person. This time we will write an employee class. An employee is a person, so using inheritance is appropriate. This gives us a derivation chart that looks like this. So baseball player and employee, they're both child of a person class. Note that employee and baseball player don't have any direct relationship, even though they both inherit from person. It's possible to inherit from a class that is itself derived from another class. There's nothing noteworthy or special when doing so. Supervisor is an employee. Supervisor is an employee, which is a person. Can we do like circular inheritance? I think that would cause a compiler error, I'm guessing. Inheriting from a base class means we don't have to redefine the information from the base class in our derived class. We automatically receive the member function and member variables of the base class through inheritance. Okay. Order of construction of derived classes. In the previous lesson on basic inheritance in C++, you learned that classes can inherit members and functions from other classes. In this lesson, we are going to take a closer look at the order of construction that happens when a derived class is instantiated. First, let's introduce some classes that will help us illustrate some important points. So base, we have an ID and then get ID, and then we have a derived class, we have a cost, and then this is the constructor, then get cost. Class derived is derived from class base. Because derived inherits functions and variables from base, you may assume that the members of base are copied into derived. However, this is not true. Instead, we can consider derived as two-part class, one part derived and one part base. You've already seen plenty of examples of what happens when we instantiate a normal class. Base is a non-derived class because it does not inherit from any other classes. C++ allocates memory for base, then calls base default constructor to do the initialization. Let's take a look at what happens when we instantiate a derived class. If you were to try this yourself, you wouldn't notice any difference from the previous example. But behind the scene, things happen slightly differently. As mentioned above, derived is really two parts, a base class and a derived part. When C++ constructs derived object, it does so in phases. First, the most base class at the top of the inheritance tree is constructed. Then each child class is constructed in order until the most child class is constructed last. So when we instantiate an instance of derived, first the base portion of the derived is constructed. Once the base portion is finished, the derived portion is constructed. At this point, there is no more derived classes, so we are done. This process is easy to illustrate. So base, or when we construct this, we do see out base. When you construct this, we do see out derived. So instantiating base, and then base is called, and then instantiating derived, both base and then derived is called. Order of construction or inheritance chain. It is sometimes the case that classes are derived from other classes which are themselves derived from other classes. For example, A, B public A, C public B, D public C. Remember that C++ always construct the first or most base class first. Here's a short program that illustrates the order of creation all along the inheritance chain. Constructing A, constructing B, constructing C, constructing D. So A, and then AB, and then ABC, and then ABCD. Constructors and initialization of derived classes. In the past two lessons, we have explored some basics around inheritance in C++ and the order that derived classes are initialized. In this lesson, we will take a closer look at the role of constructors and in the initialization of derived classes. To do so, we will continue to use the simple base and derived classes we developed in the previous lesson. With the non-derived classes, constructors only have to worry about their own members. For example, consider base. You can create base object like this. Here's what happens when base is instantiated. Memory for base is set aside. The appropriate base constructor is called. The memory initializer list initializes variable. The body of the constructor executes. Control is returned to the caller. Okay, wait, just want to remember something from the first chapter. Never mind, I will just review it later. This is pretty straightforward. With derived classes, things are slightly more complex. Here's what actually happens when derived is instantiated. Memory for derived is set aside. The appropriate derived constructor is called. The base object is constructed first using the appropriate base constructor. If no base constructor is specified, the default constructor will be used. The member initializer list initializes variables. The body of the constructor executes. Control is returned to the caller. If the base object is constructed first, when is the derived object constructed? Derived constructor is called. The base object is constructed first. Okay. So it initializes all the variables for both base and derived. The only real difference between this case and the non-inherited case is that before the derived class can do anything substantial, the base constructor is called first. The base constructor sets up the base portion of the object. Control is then returned to the derived constructor, and the derived constructor is allowed to finish up its job. One of the shortcomings of our derived class as written is that there is no way to initialize ID when we create a derived object. What if we want to set both mcost and ID when we create a derived object? New programmers often attempt to solve this problem as follows. Const ID, cost. This is a good attempt and is almost the right idea. We definitely need to add another parameter to our constructor. Otherwise, C++ will have no way of knowing what value we want to initialize ID to. One of the shortcomings of our derived class as written is that there is no way to initialize ID when we create a derived object. New programmers often attempt to solve this problem as follows. However, C++ prevents classes from initializing inherited member variables in the member initializer list of a constructor. In other words, the value of a member variable can only be set in member initializer list of a constructor belonging to the same class as the variable. Why does C++ do this? The answer has to do with const and reference variables. Consider what happens if id were const, because const variables must be initialized with a value at the time of creation. The base class constructor must set its value when the variable is created. However, when the base class constructor finishes, the derived class constructor's member initializer lists are then executed. Each derived class would then have the opportunity to initialize that variable, potentially changing its value. By restricting the initialization of variables to the constructor of the class those variables belong to, C++ ensures that all variables are initialized only once. The end result is that the above example does not work because id was inherited from base and only non-inherited variables can be initialized. However, inherited variables can still have their values changed in the body of constructor using an assignment. While this works, it wouldn't work if id were constant or a reference. It's also inefficient because id gets assigned a value twice. Once in the member initializer list of the base class constructor and then again in the body of the derived class constructor. And finally, what if the base class needed access to this value during construction? It has no way to access it since it's not set until the derived constructor is executed. So how do you properly initialize id when creating a derived class object? C++ gives us the ability to explicitly choose which base class constructor will be called. To do this, simply add a call to the base class constructor in the member initializer list of the derived class. So derived, we do base id, call base int constructor with the value id. When we execute this code, so the 1.3 and 5, the base class constructor will be used to initialize id. The derived class constructor will be used to initialize cost to 1.3. In more detail, here's what happens. Memory for derived is allocated. The derived constructor is called. The compiler will look to see if we have asked for a particular base class constructor. We have, so it calls base int with id 5. Base class constructor member initializer list sets id to 5. The base class constructor body executes, which does nothing. Base class constructor returns. The derived class constructor member initializer list to set cost to 1.3. The constructor executes, which does nothing, and then the constructor returns. This may seem somewhat complex, but it's actually very simple. id lives in the base portion of the object. The base constructor is the only constructor that can initialize that value. Note that it doesn't matter where in the derived class member initializer list the base constructor is called. It will always execute first. Now we can make our members private. Now that you know how to initialize base class members, there's no need to keep our member variables public. We can make our member variables private again, as they should be. Consider, so this is private id. So we are calling base class and setting the id to this. In the above code, we made id and cost private. This is fine since we use the relevant constructors to initialize them and use a public accessor to get the values. This prints as expected. We'll talk more about access specifiers in the next lesson. Another example, let's look at another pair of classes we have previously worked with. person, and then baseball player. Baseball player only initializes its own member, does not specify a person constructor to use it. This means every baseball player we create is going to use the default person constructor, which will initialize the name to blank and age to 0. Here's an updated classes that use private members. So we have private, name and age. Private, battling average and home run. So it's setting the name and age in the person constructor. And then battling average and home runs, it's setting it over here. Classes is in inheritance chain work in exactly the same way. So public A, and then class B inherits from A. So when we construct C, A and B go to the B class, and then A goes to the A class. When a derived class is destroyed, each destructor is called in reverse order of the construction. In the above example, when C is destroyed, the C destructor is called first, then the B destructor, then the A destructor. When constructing a derived class, the derived class constructor is responsible for determining which base class constructor is called. If no base class constructor is specified, the default base class constructor will be used. In that case, if no base class constructor can be found, the compiler will display an error. The classes are then constructed in order from most base to most derived. Let's implement a fruit example that we talked about in our introduction to inheritance. Create a fruit base class that contains two private members. I updated my Visual Studio. It went back to the solutions page. It will take some time to load. Create a fruit base class that contains two private members, a name and a color. Create an apple class that inherits fruits. Apple will have additional private members, fiber. Create a banana class that also inherits fruit. Banana has no additional members. So red delicious, red. Cavendish, yellow. It has a name, color, and this is the fiber content. Because A and B are const, you will need to mind your const. Make sure your parameters and functions are appropriately const. So class fruit, right? And we need this. So const apple A class apple public. We haven't gone through public yet. Fruit class banana public fruit. Class fruit has is the name and color constant. Make sure your parameters and functions are appropriately const. So const std string name and then const std string color. Does it have any constructor? Apple should have additional member, and these are private. Private and what else? Const double fiber. Public Apple we have const std string name const std string color and const double fiber. And this is m underscore name. Member member and public fruit we have these two, name and color. Yep, getting them by reference. And then underscore name is name, comma, m underscore color is color. Then over here we will call fruit, name and color, and what else? And fiber, m underscore fiber is fiber. Oops, what just happened? Tools. Forget it, this is good enough. So class banana public fruit, what does it do? Banana has no additional members. But If we do public banana, you have name and color, and that this calls fruit name and color. Binary, there's no operator from say the type const apple. Oh, I have to define the operator as well. I don't think I should have references. Need to override the operator std o stream reference operator. This is a friend. It's not a member of banana class. Friend operator. Then o stream out banana reference to banana const b. So out b dot name banana color b dot dot m underscore name. Return out banana name. Is this right? And now let's do same thing for apple. Apple a dot name, a dot color. Apple name and apple color. Std const std o stream Fruit M name cannot access private member declared in class fruit. Uh, std string view get name return m underscore name return get color return m underscore color. Dot get name dot get color dot get color get name. Apple fiber a dot m underscore fiber. Is this correct? Get name void cannot convert this pointer from const apple to fruit. So line 28. Cannot convert this pointer from const apple to fruit pointer. I don't understand. String view get name, the error is over here or here. This is a fruit method, right? But Apple inherited it, so Apple should have these methods as well. Cannot convert this pointer from apple to fruit. We have fruit, string view. We can do string view. But they want string, right? Not string view. I should write const here. Const here. So double get fiber const and then O stream, std O stream. I don't get what the issue is. No overloaded function could convert all the argument types. So line 26. String view. I think it's this. String view. String view. Apple name, red delicious, color red, fiber 4.2, and then banana name, Cavendish, banana color yellow. I think I should just do it like this. I should do /n, then /d. /n/d. /n/d. Red delicious, color red, fiber 4.2, banana name, Cavendish, color yellow. Inheritance and access specifiers. In the previous lessons in this chapter, you have learned a bit about how base inheritance works. Okay. In all of our examples so far, we have used public inheritance. That is, our derived class publicly inherits the base class. In this lesson, we will take a closer look at public inheritance, as well as two other kinds of inheritance, private and protected. We'll also explore how the different kinds of inheritance interact with access specifiers to allow or restrict access to members. To this point, you have seen the private and public access specifiers, which determine who can access the members of a class. As a quick refresher, public members can be accessed by anyone. Private members can only be accessed by member functions of the same class or friends. This means derived classes cannot access private members of the base class directly. Base, we have private, and we have public. The protected access specifier. When dealing with inherited classes, things get a bit more complex. C++ has a third access specifier that we have yet to talk about because it's only useful in an inheritance context. The protected access specifier allows the class the member belongs to, friends, and derived classes to access the members. However, protect members are not accessible from outside the class. Okay. So derived can access protected and public but not private. And then classes outside of derived, classes not inherited from base cannot access the protected part. So this is allowed, this is allowed, this is not allowed. When should I use the protected access specifier? With a protected attribute in a base class, derived classes can access that member directly. This means that if you later change anything about that protected attribute, you will probably need to change both the base class and all of the derived classes. Therefore, the protected access specifier is most useful when you are going to be the ones deriving from your own classes and the number of derived classes is reasonable. That way, if you make a change to the implementation of the base class and updates to the derived classes are necessary as a result, you can make the updates yourself. In general, it's better to make your members private if you can and only use protected when derived classes are planned and the cost to build and maintain an interface to those private members is too high. There are 3 different ways for classes to inherit from other classes. So inherit from base class, base publicly, inherit from base protectedly, inherit from base privately. And this defaults to private inheritance. If you do not choose an inheritance type, C++ defaults to private inheritance. That gives us line combination 3 member access specifiers and 3 inheritance types. So what's the difference between these? In a nutshell, when members are inherited, the access specifiers from inherited members may be changed depending on the type of inheritance used. Put another way, members that were public or protected in the base class may change access specifiers in the derived class. This may seem a little confusing. Keep in mind the following rules as we step through the examples. A class can always access its own members. The public accesses the members of a class based on the access specifier. A derived class accesses inherited members based on the class specifiers inherited from the private parent class. So public inheritance. Public inheritance is by far the most commonly used type of inheritance. In fact, very rarely will you see or use the other types of inheritance. So your primary focus should be on understanding this section. So access specifier in base class, public, protected, and private. Access specifier when inherited publicly, public, protected, inaccessible. So when it's publicly inherited, you cannot access the private members. Okay. Protected inheritance. Protected inheritance is the least common method of inheritance. It is almost never used except in very particular cases. With protected inheritance, the public and protected members become protected and private members stay inaccessible. Because this form of inheritance is so rare, we will skip the example and just summarize with the table. So public members, protected members, private members, if inherited protectedly, the private members will be inaccessible. All the public members will turn into protected. Oh, so So the derived class can use it and the base class can use it. But if another class derives from the derived class, they can't use it. With private inheritance, all members from the base class are inherited as private. This means private members are inaccessible, protected, and public members become private. So, base class, we are public, we are protected, we are private. Private inheritance means public inheritance members becomes private. So, M public is treated as private. M protected is treated as private. M private is inaccessible. So private as in private in this class. So classes outside cannot use this and inherited classes cannot use this. Private, private, inaccessible. So with public, it doesn't change. With protected, these two becomes protected. The private, these two becomes private. Class base. Base can access its own members without restriction. The public can only access public. Derived classes can only access public and protected. D2 can access its own members without restriction. D2 can access bases public and protected members but not private. Because D2 inherited base privately, public and protected are now considered private when accessed through D2. Okay, adding new functionality to a derived class. In the Introduction to Inheritance lesson, we mentioned that one of the biggest benefits of using derived classes is the ability to reuse already written code. You can inherit the base class functionality and then add new functionality, modify existing functionality, or hide functionality you don't want. In this and the next few lessons, we will take a closer look at how each of these things is done. First, let's start with a simple base class. So include IOStream class base, protected int value. Now let's create a derived class that inherits from base. Because we want the derived class to be able to set the value of value. When derived objects are instantiated, we will make the derived constructor call the base constructor in the initializer list. Okay. Adding new functionality to the derived class. In the above example, because we have access to the source code of the base class, we can add functionality directly to base if we desire. There may be times when we when we have access to a base class but do not want to modify it. Consider the case where you have just punctured a library of code from a third-party vendor but need some extra functionality. You can add to the original code, but this isn't the best solution. What if the vendor sends you an update? Either your additions will be overwritten or you have to manually migrate them into the update. Alternatively, there may be times when it's not even possible to modify the base class. Consider the code in the standard library. We aren't able to modify the code that's part of the standard library, but we are able to inherit from those classes, then add our own functionality. In other case, the best answer is to derive your own class. One obvious omission from base class is a way for the public to access M value. You could remedy this by adding an access function in the base class. To add new functionality to the derived class, simply declare the functionality in the derived class like normal. So get value, return M value. Weight in the base class is M value M value is protected, right? So derive can access it. Now the public will be able to call getValue on an object of type derive to access the value of M value. Although it may seem obvious, objects of type base have no access to the getValue function in derived. The following does not work. So base.getValue, this does not work. Okay. Calling inherited functions and overriding behavior. By default, derived classes inherit all of the behaviors defined in a base class. In this lesson, we will examine in more detail how member functions are selected as well as how we can leverage this to change behaviors in a derived class. First, let's explore what happens when the derived class has no matching function but the base class does. So base class, we avoid identify constant. Then derived class has nothing. We're calling base.identify and derived.identify. In both cases, we call base identify. Redefining behaviors. If you want to define derived identify in the derived class, it would have been used instead. If we had defined derived identify in the derived class, it would have been used instead. This means we can make functions work differently with the derived classes by redefining them in the derived class. Okay, so identify, base identify, derived identify, and then when we call this calls base identify, and then this calls derived identify. Is there a way for identify to call bases identify? Know that when you redefine a function in the derived class, the derived function does not inherit the access specifier of the function with the same name in the base class. It uses whatever access specifier it is defined under in the derived class. Therefore, a function that is defined as private in the base class can be redefined as public in the derived class or vice versa. Private print base, public print derived. This calls a public function. Adding to existing functionality. Sometimes we don't want to completely replace a base function, but we want to add functionality. Okay, this is what I asked. So identify, derived identify, and then base identify. We call it like this. Base identify, and then derived identify, and then it's calling base identify. Why do we need to use a scope resolution operator? If we had defined derived identify like this will cause infinite recursion. Identify without a scope resolution operator would default to identify the current class. There's one bit of trickiness that we can run into when trying to call friend functions in base classes, such as extraction operator. Because friend functions of the base class aren't actually part of the base class, using scope resolution qualifier won't work. Instead, we need to make a derived class temporarily look like a base class so that the right version of the function can be called. Fortunately, that's easy to do using static cast. So friend, this can see the members of the derived class. So in derived, static cast derived to a base object. So we can call the right version of this operator. So this static const base When converting this to base, what happens to the extra members that are defined? Do they get deleted? Because a derived is a base, we can static cast our derived object into base reference. Overload resolution in derived classes. As noted at the top of the lesson, the compiler will select the best matching function from the most derived class with at least one function with that name. First, let's look at a simple case where we have overloaded member functions. Print int, print double, and then d print int calls base print int. Now let's look at a case that doesn't behave like we might expect. Calls print double, not base print int. I mean, it works the way we expect, right? For the call print5, the compiler finds one function named print in derived. Therefore, it will consider functions in derived. Oh, this is an integer, but it calls the double version because it looks in the derived class first. Since base print int has a parameter that is a better match for int argument 5 than derived print double, you may have been expecting this function to resolve base print int. But because d is a derived, there is at least one print function in derived. The derived is more derived than base. The functions in base are not even considered. So what if we want d.print5 to resolve to base print int? One not great way is to define print int n, base print int. While this works, it's not great as we have to add a function to derived. For every overload we want to fall through to base. That could do a lot of extra functions that essentially just route calls to base. A better option is to use a using declaration in derived to make all base functions with a certain name visible from within derived. So using base print, void print double makes all base print functions eligible for overloaded resolution. By putting the using declaration inside derived, we are telling the compiler that all base functions named print should be visible in derived, which will cause them to be eligible for overload resolution. Hiding inherited functionality. Changing an inherited member's access level. C++ gives the ability to change an inherited member's access specified in the derived class. This is done by using a using declaration to identify the scoped base class member that is having its access changed in the derived class under the new access specifier. For example, consider the following base. Value public base and then print value. Because base print value has been declared as protected, it can only be called by base or its derived classes. The public cannot access it. Let's define a derived class that changes the access specifier print value to public. Class derived public base and then using base print value. This means that our code will now work. Print value, print 7. I mean, it is protected, right? Print value is public in derived, so this is okay. You can only change the access specifier of base members the derived class would normally be able to access. Therefore, you can never change the access specifiers of a base member from private to protected or public, because derived classes do not have access to private members of the base class. In C++, it is not possible to remove or restrict functionality from a base class other than by modifying the source code. However, in a desired class, it is possible to hide functionality that exists in the base class, so it is not accessible through a derived class. This can be done by simply changing the relevant access specifier. Public value. M value is private and derived. M value is public in base. This allowed us to take a poorly designed base class and encapsulate its data in a derived class. Alternatively, instead of inheriting base's members publicly and making value private by overriding its access specifier, we could have inherited base class, which would have caused all of the base members to be inherited privately. However, it's worth noting that while value is private in the derived class, it is public in the base class. Therefore, the encapsulation of value in derived can still be subverted by casting to base ampersand and directly accessing the members. We haven't learned about virtual function yet. Given a set of overloaded functions in base class, there is no way to change the access specifier for a single overload. You can only change them all. So public, using base get value, make all get value functions private. Deleting functions in a derived class. You can also mark member functions as deleted in a derived class, which ensures they can't be called at all through a derived object. So this, and then get value becomes deleted. So this would work. In the above example, we have marked getValue function as deleted. This means that the compiler will complain when we try to call the derived class version of the function. Note that the base version of getValue is still accessible though. You can call base.getValue in one of the two ways. And we can call base getValue, derived.base getValue. We can upcast derived to a base reference, and getValue will resolve to base getValue. If we are using a casting method, we cast to base reference rather than base to avoid making a copy of the base portion of derived. So far, all of the examples of inheritance we have prevented have a single inheritance, that is, each inherited class has one and only one parent. However, C++ provides the ability to do multiple inheritance. Multiple inheritance enables a derived class to inherit members from more than one parent. So we have a teacher, which is a person, and an employee. Can do this by using a comma. Public person, public employee. A mixin is a small class. A mixin is a small class that can be inherited from in order to add properties to a class. The name mixin indicates that a class is intended to be mixed into other classes, not instantiated on its own. So, class box labeled tooltip classes are mixins that we inherit from in order to create a new button class. Tooltip, public. You may be wondering why we use explicit box label tooltip scope resolution prefixes when this isn't necessary in most cases. Label setText, tooltip setText have the same prototype. If we call button setText, the compiler will produce an ambiguous function called compilation error. In non-ambiguous cases, using the mixin name provides documentation as to which mixin function call applies to. Non-ambiguous cases may become ambiguous in the future if we add additional mixins. Because mixins are designed to add functionality to the derived class, not to provide an interface, mixins typically do not use virtual functions. Instead, if a mixin class needs to be customized to work in a particular way, templates are typically used. A derived class can inherit from a mixin base class using a derived class template type parameter. Such an inheritance is called curiously recurring template pattern, which looks like this. A derived class can inherit from a mixin class using the derived class as a template type parameter. Okay, this is quite confusing. Problems with multiple inheritance. While multiple inheritance seems like a simple extension of the inheritance of a single inheritance, multiple inheritance introduces a lot of issues that can be markedly increase the complexity of programs and make them a maintenance nightmare. First, ambiguity can result when multiple base classes contain a function with the same name. For example, class USB device private long ID class network device get ID constant return MID. When C54G get ID is compiled, the compiler will look to see if wireless adapter contains a function named getID. So wireless adapter, it doesn't contain getID. Compiler then looks to see if any of the parent classes have a function named getID. See the problem here? The problem is that C54G actually contains two getIDs. One from USB device, one from network device. This function call is ambiguous, so you will receive a compiler error if you try to compile it. There is a way to work around this problem. You can explicitly specify which version you meant to call. Okay, we can do this. While this workaround is pretty simple, you can see how things get complex when your class inherits from 4 or 6 base classes, which inherit from other classes themselves. The potential for naming conflicts increases exponentially as you inherit more classes. Second and more serious is the diamond problem, which your author likes to call the diamond of doom. This occurs when a class multiply This occurs when a class multiply inherits from two other classes, which each inherit from a single base class. This leads to a diamond-shaped inheritance pattern. For example, consider this. Power device, scanner, printer, copier. And a copier is a scanner, which is a power device. Copier is a printer, which is a power device. A copy machine incorporates the function of both scanners and printers. There are many issues that arise in this context, including whether the copier should have one or two copies of power device, and how to resolve certain type of ambiguous reference. While most of these issues can be addressed through explicit scoping, the maintenance overhead added to your classes in order to deal with the added complexity can cause development time to skyrocket. Is multiple inheritance more trouble than it's worth? As it turns out, most of the problems that can be solved using multiple inheritance can be solved using single inheritance as well. Many object-oriented languages do not even support multiple inheritance. Many relatively modern languages such as Java or C Sharp restrict classes to a single inheritance of normal classes, but allow a multiple inheritance of interface classes. The driving idea behind disallowing multiple inheritance in these languages is that it simply makes the language too complex. You have already been using classes using multiple inheritance without knowing. The IOStream library objects stdcn and cout are both implemented using multiple inheritance. Summary and quiz. I might do like a short quiz. The quiz is pretty long, but I might do like small part of it and then I will end the stream. Inheritance allows us to model and is a relationship between two objects. The object being inherited from is called the parent class, base class, or superclass. Yeah, I get it. For each of the following programs, determine what they output or if they would not compile, indicate why. This exercise is meant to be done by inspection, so do not compile these. So base, we have constructor, destructor, derived, derived D. This will work. Construction happens in order. Wait, this will compile. Determine what they output. Okay, so if we do derived D, this will call derived. No, first it will call base and then derived, and then it will get rid of derived, and then it will get rid of base. So base, derived, derived, base. So base, derived, derived, and base. So this will work when in line 31 we will have base first and then derived, and then in line 32 we have base, and then when it goes in line 35 we have we are removing B, so this is called, and then we are removing D, so this is called, and then this is called. So base, derived, base, and then base destructor, then derived, then base. No, wait, this is called first, and then this is called. Private X, base, destructor, print, and then public print. If we do D print, you're accessing the X value, but the X value is private. So I guess it wouldn't compile. Doesn't compile. Derive print can't access private member X. D, we are calling print. We are calling X. X is protected, so this would work. Okay. No print function here. So base, derive, derive 2. Oh, that's the solution. Print t dot print. This would call this function, and X is protected. Yeah, derived 5. Write an apple class and a banana class that are derived from a common fruit class. Fruit should have two members, a name and a color. The following program should run. But I already did that. My apple is red, my banana is yellow. That are derived from a common fruit class. The fruit should have two members, a name and a color. Let's see. So this goes here. And should there be a default color? A dot get name, B dot get name. It will resolve to this, right, which will give the name and color. But the color is not defined. This is the default. This is the default. And then name 0.0. Then name apple. And then color red. Then color yellow. Then name, I'll just call it banana. So name, color, we have name and color. Color default to red. My red is red and banana is yellow. Name apple. Color red. Why does it say my red is? Oh, this constructor is wrong. So we need to remove name from here. Name remove. Call apple. Apple. Name remove. And then call fruit. Banana. Okay. Now add a new class to the previous program called Granny Smith that inherits from Apple. The following program should run. Right, Granny Smith C. Granny Smith apple is green. Oh, so Granny Smith is like a type of apple. It's a particular species of apple, right? Granny Smith class Granny Smith public apple and public Granny Smith. Uh, it calls apple. It calls apple green. My apple is green, but my Granny Smith apple is green. So private, we have red. I think we should define a get name. Std string view and get name, return Granny Smith apple. Let's see what they did. Apple. Oh, they defined another constructor. Okay, that's a good idea. Can take this, and in the apple function, private protected, we have this apple constructor, but it has a name. Apple name. Let's see, fruit, apple, color, fiber. We call this name. Now, if I do this, initializing cannot convert initializer list to apple. What's the issue? To apple. Ambiguous call to overloaded function. There's no fiber, so I think we can remove that. No fiber, no fiber. No fiber. Fiber is not a member. Yeah, no fiber. It still says this. String view, name color. Let's see. Name color. And then public is apple color. And public is apple color. Why does it say ambiguous call overloaded function? Let's see what's the issue here. Shouldn't it just call this function because there are two? Um, I don't know what's happening. Uh, Maybe it's the const. No, initializing apple. Ambiguous call to overloaded function. I think it's this. It's the default values that are red. So either you provide color. Maybe this would work. Yeah, because if I did default, then it would cause an issue. Const. The following quiz question is more difficult and lengthy. We are going to write a simple game where you fight monsters. The goal of the game is to collect as much gold as you can before you die or get to level 20. Our program consists of three classes: a creature class, player, and monster class. Player and monster both inherit from creature. First, create the creature class. Creature have 5 attributes. Okay, let's go back up. Class creature. 5 attributes. Name, symbol. Okay. A name which is std string name. A character symbol. Int health. These are all private. Private. Int health. The amount of damage they do per attack. Attack underscore damage, which is an integer. Gold, which is also an integer. Implement these as class members. Write a full set of getters and a get function for each member. Sure. And what should they be public or protected? Creature O add gold, reduce health. So creature health and is carrying gold. So std string view get name return. I should write m underscore. Why is it doing this? M underscore name. Nope. X get symbol m underscore symbol. This is character. We have int get health m underscore health and then get gold. And then also we have void add gold int gold m underscore gold plus equal to gold. We have reduce health. We have reduce health int health m underscore health is minus health. Oh, there's no constructor and this should be public. All of this, I like it when public and all of this is on the same line. Creature default. Okay. std string view name just write it like this, jar s int h int attack damage and then int gold. And underscore name is n m underscore symbol is s m underscore health is h m underscore goal is g m underscore attack damage is ed. Let's see how they did it. String view, okay. Why didn't they do string view? Why do they do it like this? The orc has 3 health and is carrying 15 gold. And why are they all constant? Constant string reference. Now we are going to create a player class. The player class inherits from creature class. Player has one additional member, the player's level, which starts at 1. Class player, which public creature private player's level, which the player has a custom name entered by the user symbol at, has 10 health, does 1 damage to start, and has no gold. Write a function called level up that increases the player level and damage rate. Player level starts at 1, so int level. So he has a level. Custom name does 1 damage and has no gold. Player hold on. We can do it like this, right? Creature. The player has a custom name entered by the user. Std string view n. So n user symbol at. User symbol at has health 10, does 1 attack damage and has no gold, and the level is 1. So start with level 1. This is like this. Enter your name, Alex. Welcome, Alex. You have 10 health and are carrying 0 gold. STD, see out. Welcome. And welcome, Alex. You are carrying ten health. You have 10 health, are carrying 0 gold. STD string name, STDCN name, and then player P name. Isn't this correct? Syntax error. Oh, here. Alex. Welcome, Alex. You have 10 health and are carrying 0 gold. Enter your name. STD out. Enter your name. Level 1. Oh, they just do it like this. I think either way would work fine. I don't think there's a preference. So player. Oh, I need to add other functions. Finally, write has one that returns to the player has reached level 20. Wait. Level up that increases player level and damage by 1. So void level up. Level is plus equal 1. And attack damage. Is this protected? Because I have it private. Did they make it protected? Yeah, they did. Protected. Attack. Attack damage. They should be M underscore level. Wait. attack damage. Attack damage increases by 1, right? So does also write a getter for level member. So and get level return m underscore level. Write a function has one that returns true. Boolean has one. Return m level is more than equal to 20. Add goal reducer. Wait, I think there were some functions I missed in the previous one. Getters. Three other functions: reduce health, is dead, and add gold. Reduce health, is dead, and add gold. Reduce health, void is dead. Return health is less than or equal to 0. That is correct. Level up, get level has 1. Okay. Enter your name, player name, welcome. Oh, they put the welcome string over here. Next up is the monster class. Monster also inherits from creature. Monster have no non-inherited member variables. Class monster public creature. Write an empty monster class inheriting from creature and then add 3 enum inside the monster class named type and contains enumerator for the 3 monsters that we'll have in this. Add an enum name type. So enum type dragon orc slime. Dragon orc slime. We also want max type. Max underscore type. And this is public, yeah. Public. And we don't need this. Each monster type will have a different name, symbol, starting health, gold, and damage. Here is a table for stat for each monster type. Symbol, health, damage, gold. Next step is to write a monster constructor so we can create monsters. The monster constructor should take a type enum as a parameter and then create a monster with the appropriate stats for that kind of monster. So a monster constructor, the input will be type T and then Let's see how I can do this. You're calling creature. Get starts. Let's define this first. Creature. Get starts type t. If t is equal dragon, return creature D2400. D2400. And we also need the name, right? Any name dragon. Else if t is orc, return creature orc. Also, this needs to be double quote. Return orc 04225. 04225. Else if t is equal slime, then slime guessing s 1110. 1110. Get starts t. I think this should work, right? Monster constructor should take the type enum as a parameter, then create a monster with appropriate stats for that monster. There are different ways to implement this, some better, some worse. However, in this case, better because all monster attributes are predefined. We can use a lookup table. Our lookup table will be a C-style array of creature where indexing the array with type will return the appropriate creature for that type. Since this is a creature table, since this creature table specific to monster, we can define it inside the monster class as this, initialized with our creature element. Let's see if what I made works. Monster type orc. A get name, get symbol was created. Health undeclared identifier. 25, 24. Oh, M underscore health. Creature is dead void. Line 25. Oh, it returns a boolean. Also, this is dead, not ID dead. Before identifier max types. In enums, do we use comma or use comma, right? Else return unknown you uh, it should throw an error, right? Let's just do unknown. So why not like what they said? Static inline creature monster data. This will return this, comma, this. Creature, 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 monster data, D. How would we do the static inline creature monster data? And let's see how they did it. Inline static creature monster data. Enum is public. This is private. Static assert. Monster data type. Why is std size array IOST? I think it's an std array. Where is size defined? IOST string view. Static assert. Syntax error static assert. Didn't they do this? I don't get. Maybe it's this. Finally, add a static function to monster named get or not the random again. They should pick a random from 0 to max type -1 and return a monster by value. I'm still confused with the random part. For should be randomized. I'll just see how they did the random part. Get random monster static. Get random monster. Or they defined their own random. Dot include. Isn't there a built-in random anywhere? Include random. So what functions? Okay, we don't have random. Okay, let's just forget about random. Okay, I will end this stream here maybe. Or should I just do this last part? The fine is set to write game logic. Here's the rules of the game for the game. One randomly generated monster at a time. Hold on. Control it. I'll just download this. I'm adding a new header file. Okay, they removed like the link goes to a not found link. So I don't think I would be implement the randomness. Let's just wait. Let me just change the full screen. So instead, what I'm going to do, static monster get monster. What is static? Why is this a different color? Why does it need to be static? Static monster get monster static. I'll just have an array of some random numbers. Array index is 0. Int random int is and then return random int index ma type dot type. How do I type dot, is it dot or is it max types? It should be like this. Index return nope, this is wrong. I should do it like this. std.size random int and I should do this with type max types. So it's between 0 to 3. So I'll just have ten, 102, 12, 0, 32, 120, and then 54, and then 10 again. It's a 5, 8. There. So let's see. Int assumed. Not, wait. Get monster. Return random integer. Random ints. Int num is this. And then return monster data. Return monster. Return monster, and we need to use monster data, right? Static cast type enum num. Why mention this code as static? Int assumed. Oh, index. A call to non-static member function requires an object. Oh, static, it will belong to the class, right? Process exited with code. What is the issue? Int 0, get random monster, static index. 0, 1, 2, 3. Std size random ints. Std cout num. Okay, how is it 54? Wait, index std size random int, and then yeah, this should be here. Dragon was created, a dragon was created. Oh, I need to actually increase index. Index plus plus. Dragon, dragon, slime, dragon, dragon. Okay. Why is there space here? Let's do 2. Slime, dragon, dragon, slime, dragon, 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 slime. Where's the orc? Orc is 0, 1. Orc was created. There are no even numbers, but there are barely any even numbers. 31, 1. I mean, there are no odd numbers. Okay, anyways, the player encounters one randomly generated monster at a time. For each monster, the player has two choices, run or fight. If the player decides to run, they have a 50% chance of escaping. If the player escapes, they move to the next encounter with no ill effect. The player does not escape, the monster gets a free attack and the player chooses their next action. The player chooses to fight, the player attacks first, the monster health is reduced by the player's damage. If the monster dies, the player takes the gold the monster is carrying. The player also levels up, increasing their level and damage by 1. If the monster does not die, the monster attacks the player back. The player's health is reduced. The game ends when the player has died or reached level 20. If the player dies, the game should tell the player what level they were, how much gold they had. If the player wins, the game should tell the player they won and how much gold they had. Here's a sample game session. Enter your name. Welcome, Alex. Okay. STD string name. STD cout. Enter player name. STDCN name. So you've done that. Enter your name. Welcome, Alex. STD cout. Welcome. Name. While, hold on, player B name while P dot get level while P dot has 1 while P hasn't 1 or while P dot is dead, as long as player is not dead or player has not won, you have encountered a slime. Run or fight. So monster M monster get random monster. I think I should have this as a public constant. random int const random int global. So get random monster std cout. You have encountered a m dot get name. You have encountered a slime. Run or fight. Run or fight. Run or fight. You hit the slime for 1 damage. You kill the slime. Run or fight. stdcn choice std char choice is while choice is not r or choice is not f. You keep asking for choice. std cout run or fight. So if choice is equal r to else later. If choice is run, no, if choice is fight, then player p dot m dot reduce health p dot get attack damage. I did not set a getter function. Get symbol, get health, get attack damage. attack, damage. Fight P dot get attack damage. M reduce health, P dot get attack damage. If M dot is dead, if M is dead, then while M is not dead, you hit the slime for 1 damage. STD cout, you hit the M dot get name for P dot get attack damage. Otherwise, player dot reduce health. Then the monster will attack M dot get attack damage. The dragon hit you with 4 damage. Okay. STD cout the M dot get name hit you for M dot get attack damage for these many damage. Okay, let's see. It kills the slime. You kill the slime while M is not dead. Then STD cout you killed the M dot get name. You killed the creature. You are now level 2. P dot level up. STD cout you are now P dot you are now level this much. Now let's see. You killed the slime, you are now level 2, you found 10 gold. So does the player randomly win 10 gold? Decides to run, they have a 50% chance of escaping. Player chooses player attacks first, the monster health is reduced by the player's damage. If the monster dies, the player takes any gold the monster is carrying. P dot increase P dot add gold M dot get gold std cout you are not carrying P dot get gold gold. If the monster dies, the player takes any gold the monster is carrying. The player also levels up, increasing their level and damage by 1. The player does not die. The monster attacks the player back. The player health is reduced by the monster's damage. Yeah, if it does not die, player health is reduced by the monster's damage. The game ends when the player has died or reached level 20. Wait, if the monster does not die, the monster attacks the player back, the player health reduces, and then does the player fight again? If the player dies, the game should tell the player what level they were and how much gold they had. Reduce health. So P dot reduce health. Wait, let's just forget about this. P dot reduce health. The something hit you, and then if P dot is dead, this should be if. If monster is not dead, then the monster attacks and the player health reduces. And if the player is dead, then we break out of the loop. If the player decides to run, they have a 50% chance of escaping. So will escape is we take the random integers we do int counter 0 counter plus plus. See, let's have it at the end. We have counter which std size g underscore random integers and then by 2, and then we check if all of this is 0. This will be the 50% chance of them escaping. There 50% chance of escaping. If the player escapes, they move to the next encounter with no ill effect. So let me see what they wrote for it. You found 10 gold, you have encountered dragon, you failed to flee. If escape else std cout you failed to flee. You fail to flee. The dragon hits you for 4 damage. You successfully fled. And we have this. You fail to flee. Reduce health by monster's attack damage. Hit you for this much and the player is dead. You have encountered an orc. You hit the orc for 2 damage. The orc hit you for 2 damage. Fight. You hit the orc for 2 damage. You kill the orc. You are now level 3. So wait. If we choose if choice should be F or R, small F or small R, small F or small R. So if the monster isn't dead, this part keeps continuing, right? So reduce health by get attack damage, STDC out. Okay, so there should be a while loop. If P is dead, break, and it should break outside as well. If P is dead, then break. So reduce health. The orc hit you for these many damage. Then we give them the choice again to run or flee. Wait, char get choice. This should be over here. And then return choice. Char is equal to get choice. While monster is not dead. So choice is equal to get choice again. So while monster is not dead, reduce the player health and then give them go back here. Let me think about this. So monster M, monster, get monster. I think this should be defined outside. Or let me think about this. Like, what I want, if the monster is not dead, reduce the player health and then go back to this line. Go back to where we get a choice. Should I do recursion or should I do a while loop? Uh, let me think. Meet new monster, which will be void, and the entire while loop actually inside the while loop. Meet new monster. Play P and counter can be static. And then player by reference P can be made static. Static. And static here as well, I guess. And choice, we have static and counter 0. Counter will increment here. So they meet a new monster, and now a choice. Wait, static, void, run or fight. And then this. What's happening? Okay, player P and then monster M. And then we do run or fight. Monster M P M. So you meet the new monster and everything to do with the get choice is over here. Return M. So run or fight. We get the choice. Reduce health. I think we do this here while monster is not dead or player is not dead. That is dead. Hold on, what am I thinking? Get choice. If choice is F. I am confused. Meet monster. Hold on, let's put the run case over here. So, no, but then like failed to flee, successfully fled. You have encountered an orc. You fight the orc, you hit it, the orc hits you, and then and then the choice to run or fight comes again. So choose fight. If they choose fight, while the monster is not dead, break. Attack damage. Let's see. So player monster's health gets reduced. You hit the monster for this many damage while the monster is not if the monster is not dead, the player's health gets reduced. The monster attacked you for these many damage and then you return. And then while the monster is not dead or player is not dead, you do this again. Yeah, while monster is not dead or player is not dead, you run or fight again. So it goes back. So return. Shouldn't return anything. Initializing cannot convert from white to monster. Run or fight PM. Return M. $75. Empty character constant. While I'll just put 0. Meet new monster. White function returning a value. This should be monster. Following is treated unreferenced formal parameter 83. Line 83. New monster. illegal break, line 119. What? Line 119, illegal break. Oh. So if the monster is not dead, the monster attacks player and then we return. We return so we can go to the start of the function back again. If the okay. Free the monster, you kill the monster you're carrying, and encounter a dragon. You are now level 3, you have found 25 gold. You're now. Wait. The player chooses to fight. The monster is reduced by the player's damage. If the monster dies, the player takes any gold. Player also levels up. So you have found 25 gold. So you have found these many gold. So if p dot is dead, std out, you lost with p dot get level. You lost at level this much, and p dot get gold gold else std out, you won with p dot gold. Okay, let's see how well it works. Enter your name, Alex. Run or fight. Wait, I don't like the space with the F. Let's try again. Alex, run or fight? Maybe we should remove the space here as well. So, run. You successfully fled. Run or fight again. Why does it say run or fight again? There's a mistake here. You successfully fled, and we have to meet a new monster. So I have to kill this one. Uh, Maybe I have an idea. Boolean escaped is equal to false. While monster is not dead and the player is not dead, and not escaped. Escaped is this will return a boolean. Then escaped is false. You successfully fled. Hold on. You successfully fled and return escape. Let's see how well it works now. Not all control paths have a value. Yeah, I think I should do this. Return true. They killed the monster and then they went, so I will set escaped as true. Alex, run or fight, run. Successfully fled. You encountered a slime, run again. You successfully fled. You encountered a dragon. Why is there a space? Run again. You failed to flee. The dragon hit you with 4 damage. Dragon hit you 4 damage. Run again. Failed to flee. Oops. So either the monster is alive. No, either the monster is dead or the player either the monster is dead or the player. Hold on, why am I getting confused? If the monster is alive or the player is alive, no, and the player is alive, and the player did not escape. Here they killed it. So monster is dead. Right. You hit the slime, you kill the slime, you're now level 2. I only pressed run, right? While the player is alive or player has not won. Alex, you encountered an orc, fight the orc, you hit the orc for 1 damage, the orc hit you for 2 damage. Hit the orc for 1 damage, the orc hit you for 2 damage. Fight again. Oh, you hit the orc for 1 damage, you hit the orc for 2 damage. Now what's the health of the orc? Orc has 4 health. You killed the orc. You killed there shouldn't be a space here. You killed the orc, you are now level 2, you have found 25 golds. You have encountered a slime. Fight. Hit the slime for 2 damage, you killed the slime, you are now level 3, you have found 10 golds, you encountered a dragon. Wait, what's happening? Hit the dragon for 3 damage, the dragon hit you for 4 damage, you have encountered an orc. Why does it go into an infinite loop? Enter your name, Alex, fight. You hit the orc for 1 damage, the orc hit you for 2 damage. 2 damage. Hit the orc for 1 damage, you kill the orc, you are now level 2, you have found 25 gold, you encountered a slime. Fight the slime. Hit the slime for 2 damage, you kill the slime, you are now level 3, you found 10 golds. You have encountered a dragon. Why does it go into an infinite loop? I guess that dragon wins and then the escape becomes false. Player is dead. Okay. If player is dead, then break. If player is dead, then send this message. If p dot has won, also break, and then send this message. And I think we need a do while. Do this while true. Now let's try. I need to close this. Enter your name, Alex. Fight the orc. Fight, fight, fight. Hit the orc for 1 damage. You are now level 2. Fight the slime. I kill the slime. Fight the dragon. Hit the dragon for 3 damage. You hit the dragon for 3 damage. So the dragon hit you for 4 damage. You lost at level 3 and 35 gold. So how do we win? So this works now. Let's try. Enter your name, Alex. Fight, 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 fight. Fight the slime. Run from the dragon. You successfully freed. Never encountered an orc. Fight. Fight. Fight the orc. Fight the orc. Run from the dragon. You failed to flee. The dragon hit you for 4 damage. You lost at level 6 with 110 gold. Okay, I think there's a way. We first fight the slime. So Alex, forget the orc. Fight the slime. You're now level 2. Keep running. Okay. So Alex, run from the orc. Fight the slime. Fight the dragon. You're the dragon for 2 damage. The dragon hit you for 4 damage. Fight. Fight. I lost. The dragon is tough. Alex, run from the orc. Fight the slime. Run. Fight. Run. Let's put 10 over here. Let's see if we get anything different. Let's put 50. And let's put 2 here. Anyways, enter your name, Alex. Run. Fight. 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 Run. Fight. Fight. Fight the orc. Fight the orc. Run from the dragon. You fail to flee. What happens if we fight the first orc? Alex, fight the orc. Fight. Let's flee. Let's try to run from the orc. Run. Run. Fight. Run. 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 In run or fight, the counter increases. Let's increase the player health by, let's say, 100. Level 1 creature. Symbol health. Health is, let's say, 100. Alex. Orc, run. Run from this orc. Fight the slime. Run, 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 run. Fight the orc. Fight the orc. Fight the orc. Fight the orc. Run. I can't. Yeah. Now fight the slime. Fight the slime. Fight the slime. Fight the slime. Fight the dragon. Fight orc. Fight the slime. Fight the orc. Fight the slime. And then fight the dragon. You are now level 20. You have found 100 gold. You won with 565 gold. I think every time we encounter a monster, we should just add a new line. It's more readable. Yeah, the dragon is the issue. Alex, fight, 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 run, run, fight, 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 run, run, run. How many dragons? Fight. Keep fighting the slime. Now let's fight the dragon. Now let's fight everyone. You are now level 20. You have found 25 golds. Even one. Okay, this was fun. Let's see how they implemented. But they use random.h. Attack monster. So what does their main function look like? The player is not dead, a player. Then fight monster. If it's dead, then return 0. Shouldn't they break out of the loop? Or only this is the while loop? Yeah, fight monster. Player or get random monster. 50% chance of fleeing. Success ends the encounter. Okay, never mind this. I will end the stream here then. It took longer than expected. And yeah, next stream I might do math. Even yesterday I said I would do math, but I'm not really sure. So see you guys next time. Bye.